Good afternoon, everyone, and welcome to the latest episode of our MSME Masterclass. In today's session, we will be discussing material systems that help speed up high-rise construction and how the right choice of materials and construction methods can significantly influence project timelines, safety, and execution efficiency. Joining us today is Mr. Shrinivas Rathi, partner at Aaditi Enterprises, a firm operating in the infrastructure and construction sector. Mr. Rathi brings over 25 years of experience in construction execution, having worked across a wide range of infrastructure and industrial project environments where site discipline, safety management, and coordination across contractor teams are critical to successful project delivery. His work involves overseeing on-site operations for projects involving structural steel, fabrication, and heavy construction, giving him a deep understanding of how material choices translate into real-world construction speed and efficiency. Given the growing demand for faster project execution in steel-intensive and high-rise construction, his perspective offers valuable insights for MSME contractors, fabricators, and construction teams looking to improve productivity while maintaining safety and quality standards. Mr. Rathi, we're delighted to have you with us today. Welcome to our MSME Masterclass.
Yeah, good afternoon, Sean. I'm Shrinivas Rathi from Chhatrapati Sambhajinagar, Maharashtra. Its old name is Aurangabad. Yeah.
So we'll quickly jump on to our first question for today's session. Can you tell our attendees what do we mean by integrated site systems in high-rise construction?
Site system in high-rise construction means a coordinated approach where all site activities, materials, labor, equipment, logistics, and safety are planned and managed together as one uniform system. Instead of working separately, these elements are linked to a proper planning and often digital tools so that construction runs smoothly and efficiently. It ensures that the right materials arrive at the right time, the right workers are available when needed, equipment like cranes and hoists are properly scheduled, all activities are synchronized to avoid delays and conflicts. In high-rise, projects involve limited space, multiple floors and team working simultaneously, heavy dependence on cranes and vertical support. So integration helps them to reduce delay, improve productivity, enhance safety, optimize resource use. In short, integrated site systems refer to the centralized and coordinated management of all construction site operations to ensure efficient, safe, and timely execution of high-rise projects.
So why is there a growing need to rethink traditional site execution methods today?
There is a growing need to move away from conventional fragmented construction practice because the demands of high-rise projects have fundamentally changed. But the old ways of working haven't kept up. In traditional construction, activities like formwork, safety, and material handling are managed in isolation. This fragmented approach creates delays due to poor coordination between teams, unpredictable timelines because each activity depends on manual adjustments, higher rework and inefficiencies, safety risks, especially in high-rise environments. Today, however, projects are under much greater pressure, tighter deadlines from developers and investors, rising labor costs and skill shortages, stricter safety and compliance requirements. Because of this, the old adjust on-site approach simply doesn't work anymore. What the industry needs now is predictability instead of improvisation, system instead of isolated process, planning-driven execution instead of reactive problem solving. Fragmented practice slow everything down because one delay, say formwork, affects safety setup, which then affects finishing and even base handling. So the shift is happening toward integrated system-based construction where everything is aligned from the beginning. The complexity and speed required in modern high-rise construction demand a more coordinated, efficient, and scalable way of building. And that's why moving away from fragmented practices is no longer optional but necessary.
So tell us, what are the key factors that determine slab cycle time in high-rise buildings?
The slab cycle time, essentially the number of days it takes to complete one floor, is one of the most critical drivers of high-rise construction speed. It is not controlled by a single factor, but by how efficiently multiple elements come together. The formwork system, this is the biggest driver. Conventional shuttering is like slower, more labor intensive. In modular systems like plastic and aluminum formwork, these are the faster, repeatable cycles. The more standardized and reusable the system, the shorter the cycle. Then planning and sequencing, clear activity sequences like shuttering, reinforcement, MEP, concreting, stripping, avoid clashes between the teams. Poor planning can easily add 1 to 2 extra days per slab. Skilled crews can execute repetitive tasks faster. Familiarity with the system improves speed over time. Learning curve matters, especially in early floors. On concrete performance, the setting up time and early strength and gain, use of admixtures for faster curing, faster strength gain, early deshuttering, and quicker next cycle. Availability of tower cranes, pumps, and lifting system, breakdown or congestion slow process. There is a coordination between the traders, structural, MEP, and finishing teams must work in synchronization. Delays in one activity affects all others. That is the slab cycle.
Understood. Now, so tell us, how does plastic formwork compare with conventional shuttering in terms of speed and efficiency?
This plastic formwork represents a clear shift from labor-intensive variable processes to more standardized and repeatable systems, and that's where the gain in speed and efficiency come from. With conventional shuttering, cutting, fitting, and adjustments are done on site. Every cycle, more dependency on carpenter skill. The typical slab cycle time for the conventional shuttering is 10 to 12 days. With a plastic form or aluminum form, these panels are pre-designed, modular and easy to assemble. Minimal cutting or modification required. There is a typical slab cycle for plastic and aluminum form 3 to 5 days. The difference comes from repeatability and reduced setup time. There is a labor efficiency that there is a conventional, required skilled carpenters, high manpower requirement, more supervision needed. In the plastic formwork and aluminum formwork can be handled by semi-skilled labor, lower manpower per slab, faster learning curve after initial cycles. There is a consistency and the quality in the plastic formwork. In the conventional shuttering, variation in workmanship, surface finish may require additional plastering. In the plastic and aluminum formwork, uniform finish across floors, reduced need for rework and corrections. As far as the handling and weight is concerned, conventional, there is a timber or steel they are using. It's heavier and harder to move. Slow shifting between floors. On plastic and aluminum formwork, this is lightweight and easy to handle. Faster movement and repositioning. As reusability is also there. In conventional, limited reuse due to wear and damage. In the plastic formwork, higher reuse cycles with proper handling, maintain shape and dimensions over time. Plastic systems contribute to cleaner, more organized sites, less material wastage, faster turnaround between the activities. The K factor is the plastic formwork reduces on-site improvisation, enable predictable, repeatable slab cycles, lowers dependency on higher skilled labor, improves overall workflow consistency. Yeah.
Got it. So tell us, what kind of time savings can developers realistically expect by adopting modular formwork systems?
The time savings from adopting modern systems like plastic formwork, integrated safety and organized waste management can be significant, but they depend on how well the system is implemented. As far as the slab cycle is considered, in conventional systems, slab cycle is a 10 to 12 days per floor. With system-based approaches like plastic formwork, it's a 5 to 6 days per floor. That's a 30 to 50% reduction in cycle time. For a typical 25 to 30 store building, conventional method is 18 to 12 months. That's a structural phase. With integrated system, it takes only 10 to 12 months. The potential savings are the 6 to 10 months for the 25 to 30 story building. There is the indirect time saving like beyond slab cycles. Additional time is saved through faster material handling, reduced rework due to better quality, fewer delays from safety issues or site congestion, smoother coordination between trades. In the initial 2 to 3 floors, speed may be slightly slower as teams adopt, but after that, cycle becomes highly consistent and predictable. Yeah, that's.
Got it. So we've heard a lot about common challenges that contractors face. Tell our attendees what are these common challenges when shifting to plastic formwork?
While plastic formwork offers clear advantages, contractors often face a few practical challenges during adoption, especially in the early stages. Most of these are not technical limitations but transition related issues. Initial mind shift is there. Many teams are used to conventional shuttering where adjustments can be made on site. Flexibility is high. With plastic formwork, the system is pre-planned and standardized. Less room for on-site improvisation. This requires a shift from adjust on site to plan before execution. Workers may not familiar with the modular systems. Initial cycles can be slower. Incorrect assembly can affect alignment. Typically, it takes 2 to 4 slab cycles for teams to become efficient. Plastic formworks work best when drawings are finalized early. Floor layouts are repetitive. Challenges arise when frequent design changes occur. Coordination between structural and MEP teams is weak. Although lightweight panels need proper handling to avoid damage, organized storage and tracking, poor site discipline can reduce reusability. Initial costs may appear higher than conventional shuttering. Contractors may hesitate without understanding life cycle benefits. The savings come over multiple reuse cycles, not immediately. Limited flexibility for irregular designs works best for repetitive layouts. Complex or highly customized designs may require adjustments or hybrid systems. There's a coordination between the other activities like opening for MEPs, leaves, etc. must be planned in advance. Late changes can disrupt the system. Most challenges are temporary and manageable. Initially, learning curve, need for better planning, change in execution mindset. Once these are addressed, contractors typically experience faster cycles, lower dependency on skilled labor, more predictable outcomes. Yeah, that's all.
Okay. And how important is repeatability and standardization in achieving faster slab cycles?
The standardization and repeatability are absolutely critical to achieving consistent slab cycles. In fact, they are what make fast construction sustainable, not just a one-time success. Turning work into a system without standardization, every floor is treated like a new problem. Teams spend time adjusting, correcting, and coordinating with standardization. Each floor follows the same process, same sequence, same setup. This transforms construction from variable activity into predictable systems. Consistent cycle timers, repeatability ensures the same formwork layout, the same activity sequence, the same team coordination. It gives a result that slab cycle become consistent instead of fluctuating. Faster learning curve. When tasks repeat, workers become more efficient with each cycle. Error reduces significantly. Productivity improves naturally. By the fourth or fifth slab, teams often reach peak efficiency. There is a better planning and the coordination. Standardized system allow predefined schedules, better material planning, smooth coordination between structural, MEP and finishing teams. Fewer surprises are the fewer delays. Whenever you get some challenges in the work on each floor, the project may get delayed. Reduce rework and waste. Repeatable systems minimize errors in alignment and dimensions, reduce material wastage, improve overall quality of product. Scalability across projects. One system is standardized, it can be replicated across multiple towers of the projects. Contractors don't need to start from the scratch every time. Speed comes from consistency and consistency comes from standardization and repeatability. Without them, even the base materials of system won't deliver results. With them, slab construction becomes faster, more predictable, easier to manage. Standardization is what turns fast construction into reliable construction. Yeah.
Understood. So we let's dive deeper into the strap railway systems part. According to you, how do strap rail systems improve safety compared to traditional edge protection methods?
These strap rail systems improve safety by replacing temporary improved edge protection with a designed, engineered, and repeatability safety solution, which is critical in high-rise construction. Engineered versus improvised safety. Traditional methods often involve bamboo pipes or loosely fixed guardrails. Inconsistent installation quality depends on worker judgment. Strap rail systems are engineered for load resistance and stability. Follow defined safety standards provide uniform protection across the floors. This removes uncertainty and human error. In the continuous edge protection, conventional systems may have gaps or weak points, often removed and reinstalled inconsistently. In strap rail systems, it provides continuous, uninterrupted edge protection, moves systematically with the slab cycle, reduces risk of falls and significantly. In traditional anchorage, often loosely tied or temporarily fixed. In strap rail, properly anchored or structural elements designed to withstand impact or accidental force. Much higher reliability in real site conditions. In strap rail systems, the faster installation is the less exposure time. Strap rail systems are quick to install and relocate. Protection can be put in place immediately after slab completion. It minimizes the unsafe windows. The standardized height and the strength in traditional systems vary in height and spacing, may not meet safety norms. In strap rail systems, maintain consistent height, spacing, and strength designed to meet compliance requirements. Because of strap rail systems are modular, reusable, easy to inspect, they promote a more organized and safety conscious work environment. Strap rail systems improve safety because they replace temporary fixes with engineered solutions, ensure consistency and reliability across floors, reduce human dependency and error. In high-rise construction where working at height is constant, this shift from improvised safety to system-based protection can make a major difference in preventing accidents and improving overall site performance. Yeah.
Got it. Can better edge safety systems actually improve productivity on site, and if they can, how?
Yes, better edge systems don't just protect workers, but they directly improve productivity on site. In high-rise construction, safety and speed are closely linked. Reduce work interruptions like with peak or improvised edge protection, work often stops for safety corrections. Inspections may fail. Accidents or near misses cause delays with proper systems. Work continues without frequent stoppages. Fewer disruptions from safety issues. Continuous work is equal to the faster progress. Faster movement of labor and materials. When edges are properly secured, workers can move confidently across floors. Material handling becomes smoother, no hesitation near edges, less time lost in cautious movement or restricted zones. Quicker setup and relocation. Modern edge systems like strap rails are modular and easy to install, can be shifted floor to floor quickly, saves time compared to building temporary protection repeatedly. Improved worker confidence. When workers feel safe, they work more efficiently, less hesitation, especially at height. Because focus on task safety reduces psychological barriers to productivity. Fewer accidents and downtime. Accidents lead to work stoppage, investigations, labor shortage, project delays. Better safety systems minimize accidents, keep the project running smoothly. Better coordination between the activities. With reliable edge protection, multiple teams, formwork, reinforcement, MEP can work simultaneously. No need to wait for temporary safety arrangements. Enables parallel working which speeds up execution. Better edge safety systems improve productivity because they reduce interruptions, enable faster movement and workflow, support parallel activities, build worker confidence. A safer site is the faster site because work can proceed smoothly, consistently, and without avoidable delays.
What are the
Yeah.
risks of relying on temporary or improvised safety systems in high-rise projects?
Or relying on temporary or improvised safety system in high-rise projects creates serious risk, not only for worker safety but also for the project timelines, compliance, and reputation. In tall building constructions, even a small gap in age protection or access control can have major consequences. High risk of falls and serious accidents. The most obvious danger is the fall from height accidents, which remain one of the leading causes of fatalities on construction sites. Improvised systems often suffer from weak anchorage, inconsistent height and spacing, loose joints or unstable supports, gaps created during shifting. In high-rise environment, these weaknesses can quickly become life-threatening. Inconsistent protection across floors, traditional temporary methods are often installed differentially by different floors. That means one floor may secure, another may have missing rails, weak tie points, or unsafe openings. This inconsistency creates unpredictable risk zones. There are frequent work interruptions are there. When safety arrangements are make a shift, supervisors stop work for corrections. Safety audits fail. Team lose productive hours fixing temporary arrangements. What looks like a quick fix often causes the repeated delays. Then compliance and legal exposures are there. Modern projects face strict client HSE standards, labor safety regulations, third-party audits. Improvised systems may not meet load resistance requirements, height standards, proper fixing protocols. This can lead to penalties, notices, insurance issues, and shutdowns. Operating at height need trust in system around them. If safety feels weak, they work slower, avoid edge side tasks, need more supervision, productivity drops significantly. The biggest risk of improvised safety is that it creates uncertainty in the environment where predictability is essential. In high-rise construction, safety systems must be engineered, repeatable, easy to inspect, reliably across every floor. Because in reality, unsafe systems don't just risk lives, they slow projects, increase costs, and weaken trust across the site.
Okay, and how easy is it to install and relocate strap rail systems across floors?
One of the biggest advantages of strap rail system is that they are designed specifically for fast installation, easy relocation, and repeatable use across multiple floors, which makes them highly practical for high-rise construction. They are the modular and lightweight design. Strap rail systems are typically prefabricated in standard heights, lightweight enough for quick handling, designed with simple connectors or locking points. These allow site teams to install them much faster than improvised pipe or timber railing. They are the quick fixing to structural elements. Unlike temporary systems that need on-site adjustments, strap rails usually connect to predefined slab edge points. Anchors, clamps, or cast-in inserts, standardized fixing mechanism. This reduces trial and error during setup. There is a seamless floor-to-floor shifting. As the slab cycle progresses, the same system can be removed, lifted, and reinstalled on the next floor. Teams follow the same relocation sequence each cycle. This aligns perfectly with repetitive high-rise workflows. There is a minimal specialized labor needed. Once the crew is trained, installation becomes a routine activity. Semi-skilled teams can manage shifting efficiently. Usually after the first few floors, relocation becomes very fast. It supports faster slab cycles because relocation is quick, safety protection is restored early on each floor, structural and finishing teams can start work sooner. This helps maintain consistent slab cycle times. These are the better than conventional rebuilding. Traditional rest protection often means recutting pipes or timber, new trying and fixing every time, more labor and supervision. Strap rail systems eliminate this repeated setup work. Strap rail systems are very easy to install and relocate when planned as part of the slab cycle process. Their real strength lies in modular design, repetitive use, quick fixing, fast floor to floor movement. So instead of rebuilding safety systems every floor, contractors can simply shift a proven, standardized solution upward with the structure, saving both time and effort. That's it.
What should contractors look for when selecting edge protection systems?
Now, selecting the right edge protection system is a critical decision because it directly impacts safety, productivity, and compliance. Contractors should look beyond just cost and focus on a few key performance and practical factors. First and foremost, the system must meet recognized safety standards such as EN 13374, which defines requirements for temporary edge protection, including guardrail height, typically around 1 meter, road resistance and structural stability, proper intermediate rails and rope boards. This ensures the system is tested reliable, not just visually adequate. The structural strength and stability should also consider. The system should withstand impact loads, that is, worker leaning or falling against it, have secure anchorage to the structure, prevent accidental disloading. Weak or loosely fixed systems are a major safety risk. In high-rise project, system must move with the slab cycle, modular design, quick fixing mechanism, minimal tools required, faster installation, and less downtime and better productivity. As far as the compatibility and construction system, the edge protection system should integrate smoothly with formwork systems, slab edge design, construction sequence. Poor compatibility leads to delays and rework. Continuous edge protection without gaps, proper intermediate rails and toe boards, gaps or incomplete coverage are one of the biggest on-site hazards. It should have the durability and the reusability. A good system should withstand multiple reuse cycles, resist damage during handling, maintain shape and strength over time. This improves long-term cost efficiency. Impact on productivity beyond safety. Does it allow free movement of workers and materials? Can multiple teams work simultaneously? The base system supports workflow, not restricted. In short, contractors should select edge protection system based on safety compliance plus strength plus ease of use, integration with workflow, not just initial cost, because in reality the right system prevents accidents, reduces delays, improves productivity, and ultimately delivers better project performance overall. Yeah.
Alright. So now tell us, what are the biggest challenges in handling construction waste in high-rise buildings?
Handling construction waste in high-rise buildings are far more complex than a low-rise projects because of height, space constraints, and logistics. Several key challenges make it difficult. In high-rise construction, waste is generated on multiple floors. It needs to be removed safely from height to ground level without proper system. Manual handling is slow and risky. Cranes and lifts get overloaded. Moving waste vertically is one of the biggest optional challenges. There is a limited site space. Most high-rise projects are dense urban areas where space for dumping or sorting waste is very limited. Storage areas compete with materials, equipment, and access routes. Waste quickly creates congestion if not removed efficiently. There is a high volume and variety of waste. Construction generates concrete debris, steel scrap, packing material, plastic, wood, or insulation. The volume and variety makes segregation and disposal more complex. There is a safety risk. Improper waste handling can lead to falling debris hazards, blocked walkways, higher risk from packaging waste. Poor waste management directly impacts site safety. There is an impact on the productivity. When waste is not cleared efficiently, work areas become cluttered, movement of workers and materials slows down. Additional time is spent on cleaning instead of productive work. This leads to hidden delays in project timelines. Coordination and scheduling issues are there. Waste removal must be planned in synchronization with the construction progress, coordinated with transport and disposal agencies. In high-rise projects, waste often needs multiple removals per day, increasing complexity. There is an environment and compliance pressure also there. There is increasing focus on proper disposal of construction and demolition waste, dust control and pollution reduction. Poor handling can lead to environmental penalties, community complaints. The biggest challenges come down to height plus limited place plus high volume plus safety risk. That's why traditional methods struggle and high structured systems like debris tools become essential. Waste management in high rise construction is not just a housekeeping issue, it is a critical part of the efficiency, safety, and project speed. Yeah, next.
So, how do debris chutes improve site efficiency and cleanliness?
This debris should significantly improve site efficiency and cleanliness by introducing a fast, controlled, and continuous system for waste removal instead of relying on manual and scattered methods. Instant waste disposable from any floor. Without chutes, workers carry debris down manually, multiple trips waste time and energy. With debris chutes, waste is disposed of immediately at the point of generation. Materials travel directly to ground floor through a fixed path. This eliminates unnecessary movement and saves significant labor time. It reduces clutter on working floors. Construction waste often piles up because disposable is inconvenient. Workers postpone cleanup. Debris chutes encourages continuous disposable, prevent accumulation of the debris on the slab. It gives results at clean, obstruction-free working areas. Improved site organization. Instead of waste being scattered, chutes create a single designated disposable route. This leads to better site discipline, easier movement of workers and materials, more efficient use of space, faster workflow and productivity. Manual waste handling interrupts core construction work, consumes skilled labor time. With chutes, workers spend more time on productive tasks. Cleanup becomes a non-disruptive background activity. This improves overall project efficiency. Cleaner and safer environment, where debris chutes contain waste within an enclosed system, reduces dust spread and falling debris, keep walkways and access routes clear. Cleaner sites are not just better looking, they are safer and more efficient to work with. Better discipline and work culture. When disposable is easy and structured, workers are more likely to maintain cleanliness. Site standards improve naturally. Clean sites often lead to better morale and higher productivity. In short, debris chutes improve efficiency and cleanliness because they make waste removal fast, continuous, and effortless, keep work areas clear and organized, allows teams to focus on core construction activities. They convert waste management from a time-consuming task into a seamless system supporting both speed and site discipline. Next.
Can debris chute systems contribute to faster project timelines, and in what ways?
Yes, debris chute system can directly contribute to faster project timelines, and in many cases, the impact is more significant than expected because they remove a major hidden bottleneck, waste handling. You can eliminate time lost in manual debris movement. Without chutes, workers spend time on carrying debris down stairs or lifts. Frequent trips interrupt core construction work. With chutes, waste is disposed of instantly from the working floor. This saves hundreds of labor hours over the project duration. Keep workers focused on productive tasks. Manual waste handling diverts skilled labor into non-productive activities. Chute systems allow workers to stay focused on construction tasks. More productive time is equal to the faster project execution. Debris chutes enables continuous workflow. Without proper waste systems, work slows down due to clutter. Team stops to clean or clear space. With debris chutes, waste removal becomes a continuous background process. No interruptions is equal to the smoother, faster workflow. Debris chutes reduces site congestion. Manual handling leads to blocked staircase and pathways. Conflicts between workers moving materials and debris chutes. Debris chutes create a dedicated disposable channel, reduce traffic in lifts and access routes. This gives a better movement, improved coordination and speed. Clean and organized floor allow multiple teams, formwork, reinforcement, MEP to work together. Parallel execution is one of the biggest drivers for faster timelines. It minimizes delays from safety issues. Debris-related problems can cause accidents, work stoppages, inspection failures. Shoots reduce hazard and improve compliance. After each activity like concreting or finishing, cleanup is immediate and efficient. Faster turnaround between tasks helps them the right slab cycle. When waste moves faster, work moves faster, and that directly shortens the overall project timeline. Yeah, next.
So now tell us what safety and compliance benefits do organized waste management systems provide?
Organized waste management systems provide major safety and compliance benefits, especially in high-rise construction where risks and regulations are much stricter. When waste is managed systematically, work areas remain cleaner, clutter-free. Trip hazards, sharp objects, and blocked pathways are minimized. This directly reduces accidents and injuries on site. It prevents on falling debris in high-rise constructions. Unmanaged waste can fall from height, endanger workers and people below. Organized systems like designated disposable routes or chutes ensure controlled movement of debris, reducing serious safety risks. This improved fire and health safety. Poor waste handling can lead to accumulation of flammable materials, packaging and wood, dust and air quality issues. In the proper systems, keep waste segregated and removed regularly. Reduce fire hazards and environmental health risks. There stronger regulatory compliances are there. Construction projects must follow local waste disposable regulations, environmental norms, safety standards. Organized waste management helps maintain proper documentation and tracking, meet disposable and recycling requirements, avoid fines, penalties, or project shutdown. With structured systems, waste handling processes are visible and standardized. Inspector can easily verify compliance. This reduces delays during audits and approvals. There is a lower legal and financial risk. Poor waste practices can lead to accidents, environmental violations, legal liabilities. Organized systems reduces exposure to claims, penalties, and insurance issues. In organized waste management systems, prevent hazards, ensure regulatory compliance, reduce legal and safety risks. A clean and well-managed site is not just efficient, it's safer, compliant, and far easier to control throughout the project life cycle. Next.
So how do slab systems, safety systems, and waste management solutions work together as an integrated approach?
Actually, the real value of modern site executions comes when slab systems, safety systems, and waste management solutions are not treated as separate activities, but as one synchronized workflow. That is what makes them an integrated system approach. In the slab systems, there is the construction rhythm. The slab system, whether plastic formwork, aluminium formwork, or any another modular setup, defines the floor cycle timeline. For example, day 1 and 2 formwork and reinforcement, day 3 MEP insert, day 4 concreting, day 5 de-shuttering and shifting. This creates the baseline rhythm of the project. Everything else must align with this rhythm. Safety systems move with the slab cycle. As soon as slab is cast, the next floor begins. Strap rail edge protection systems are relocated upward. Access zones are secure. Material movements, parts are protected. This means safety is not added later. It becomes a planned parallel activity linked directly to slab progress. So while the slab system defines speed, the safety system ensures that speed can continue without stoppages or exposure risks. Waste systems keep the slab cycle uninterrupted. During the slab cycle, waste is continuously generated. Formwork occurs, packaging, reinforcement, scrap, concrete debris, if the remains on the slab. Movement slows, labor productivity drops, safety risk increases. A debris chute or organized waste route ensure continuously removed in real time. This keeps each slab ready for the next cycle. All three systems support parallel working. The biggest advantage of integration is the parallel execution. For example, one on the same floor, slab to complete reshuttering, trap rail is shifted, debris is cleared through chute, next crew begins reinforcement. No waiting between the activities. This is where major time savings happen. Predictability and repeatability across every floor. Once systems are aligned, the same sequence repeats floor after floor. Delays reduce drastically. Teams know exactly when their activity begins. This creates predictable slab cycles and cleaner handovers between trades. Slab systems create the speed. Safety systems protect the workflow. Waste systems maintain clean execution space. When combined, they create faster slab cycles, safer working conditions, cleaner interruption-free flows, predictable major timelines. Integration happens when structure, safety, and housekeeping all move up together, floor by floor, cycle by cycle. Next.
So now, help our MSME attendees understand what role does planning and coordination play in successfully implementing these systems.
The planning and coordination are the foundation of the successful implementation. Modern slab safety and waste systems only deliver speed when they are designed into the construction process before execution begins. Without planning, even the best systems become just another site activity. Converts system into workflow, not isolated product. A plastic former system, strap rail or debris chute is not useful on its own. Its value comes from when it is installed, who shift it, how it interacts with the next activity, how fast it moves floor to floor. Planning converts this from products into repeatable workflow systems. Align all teams to the slab cycle. In high-rise projects, multiple team work in sequence. Formwork, reinforcement, MEP, concreting, safety, cleanup. Coordination ensures each team knows exactly when the previous activity ends and the next begins. This avoids waiting time, trade clashes, duplicated work, unsafe overlap. This prevents delays caused by the late decisions. Many delays happen because safety anchors are not planned in slab edges. Chute locations interface with the lifting zone. Openings are changed late. Formwork does not align with the MEP sleeves. Good coordination slows this before site work starts. It enables floor-to-floor repeatability. The biggest benefit of planning is that once the first few floors are stabilized, the same sequence repeats, manpower becomes predictable, material movement is predefined. This is how projects achieve consistent 4 to 5 days slab cycles. It improves logistic and material flow. Planning defines when formwork is stacked, how scrap rails are lifted, where debris chutes discharge, how access routes stay clear. This avoids site congestion. Strengthens safety and compliance. Coordination ensures edge protection is the place before crew movement. Waste routes do not cross labor paths. Safety inspection aligns with the slab progress. Safer execution with fewer stoppages. It reduces hidden inefficiencies. Poor coordination creates hidden losses. Ideal cranes, waiting labor, blocked slabs, repeated cleanup, delayed handovers. Good planning removes these invisible delays. Planning defines the sequence. Coordination ensures the sequence is followed without friction. Together, they make integrated systems successfully by enabling repeatability, parallel execution, faster slab cycles, safer flows, cleaner handovers. The system succeeds not because the product alone, but because every team moves in sync with the slab cycle. Yeah, next.
Now, so how can MSMEs, primarily fabricators, suppliers, or contractors, align themselves with these modern site systems?
Nowadays, MSME can play a very powerful role in modern high-rise construction, but the shift required is from being a material vendor to becoming a system-ready execution partner. Larger developers and EPC contractors today are looking for suppliers who can support speed, standardization, and reliability, not just price. Move from product supply to system supply. Instead of only selling formwork panels, rails, tube segments, fabricated brackets, MSME should think in terms of complete deployable systems. For example, full floor-wise edge protection kits, tube system with installation accessories, reusable slab cycles, formwork sets. This increases value significantly. This build precision manufacturing capability. Modern site systems depend on repeatability, dimensional accuracy, fast assembly. So MSMEs should invest in CNC cutting, jigs and fixture, modular molds, welding consistency, standardized hole position and the connectors. Precision directly affects on the site speed. Understand the slab cycle phase delivery. Large projects work on tight slab schedules. MSME must align with floor-wise dispatch planning, just-in-time supply, predictable lead times, fast replacement support. Delivery discipline becomes the competitive advantage. Develop reusable and modular products. The market is moving forward. Reusable systems, lighter modular components, quick lock connectors, easy floor shifting. MSMEs that design product around multiple reuse cycles will stand out. Strengthen documentation and compliance. Developers increasingly expect load test data, installation manuals, quality checklists, safety compliance documents, inspection records. Documentation builds trust and helps in larger projects. Collaborate early with contractors and consultants. Rather than waiting for the purchase order, MSME should engage earlier during design review. Method statement of preparation, mock-ups and trial flows. This helps their products become part of the execution strategy. Train teams. Yeah.
Got it. So now my last question to you is, for companies still using conventional methods, what are the first practical steps for adopting, for them to start adopting these systems?
For the companies still using the conventional methods, the best way to start is not by changing everything at once, but by taking the phased practical transition approach. The goal is to move from conventional execution to a system-based workflow, one controllable steps at a time. Start with one high impact pain point. First, identify whether the project loses the most time today. Slow slab cycles, weak edge safety, poor waste management, labor heavy shuttering. Frequent cleanup delays. Start with the biggest bottleneck, not the entire project. For example, adopt plastic formwork on repetitive slabs. Introduce scrap rails on edge critical zones. Install debris tubes in vertical waste heavy areas. Pilot on one tower, one zone, or one floor sequence. Avoid full project rollout immediately. A smarter approach: one wing, one tower, one slab stack, podium to typical floor transition. This creates real project data, team learning, confidence before scaling. Standardized repetitive floor layouts. Modern system works best where repetition exists. So first, freeze repetitive floor plans, minimize design changes, standardize openings and slab edge conditions. Repeatability is the base of fast adoption. Train the site supervisors and groups early. The biggest challenge is often mindset and habit, not technology. Train teams on installation sequence, shifting procedure, handling and storage, safety checks, slab cycle timing. The first 2 or 3 floors are learning floors. Involve supplier in planning, not just procurement. Bring formwork, safety and choose vendors info, restart meetings, trial mock-ups, slab cycle planning, logistic discussions. This avoids wrong selection, poor deployment. Scale only after process stability. Once crews are comfortable, slab cycle stabilizes, logistics are smooth, then expand across more towers, more contractors, more standardized projects. Don't adopt the product first, adopt the process that allows the product to deliver speed, safety and cleanliness. Yeah, that's all.
This brings us to the end of today's episode, sir, on high-rise construction. Thank you so much for being with us and for sharing your insights with our attendees.
Yeah, thank you.
For our attendees who are online, if you've missed any part of the current episode, if you'd like to view the current episode again, please go on YouTube, type JSW One MSME, and you'll find all our episodes uploaded there. Thank you once again, sir. Bye-bye.
Thank you.